welcome back to my channel. So today we are going to discuss another DSA problem, that is linked list cycle. So this is a fairly easy program, and here we have a linked list given and we have to determine if a cycle is present in there or not. So basically what we mean that a cycle is present or not is like if it is not having a null. As you see in example number 1, we have the linked list given and position given. So this is zero based indexing, and position 1 means that it is the last node or whatever we have here is pointing again to the first index based on zero based indexing. So that's why there's an arrow there, right? So in this case we have a cycle, and in example 2 again we have a cycle and the position is 0, so it is pointing to the first node. And in the third example, we don't have a cycle because position is -1. Okay, and we have to solve it in O1 constant memory. So in the question, position is not present, but internally, I mean in the test cases and all, we have that, I mean the linking, the cyclic or the non-cyclic linking already there. Okay, so let's see how to code this. But prior to that, the demonstration. Now, Um, as you know that by cyclic we mean that there won't be a null node, right? So in the diagram we have this as like there's no null pointer present, right? There's no node pointing to null. And in this one we have our usual cases, like at the end of the linked list we have a null. Okay, so based on the question which we have, let's dry run this. 320 minus 4. Okay. Okay, so for this, let me just put an iteration here for simplicity. So zeroth iteration. Okay, how we are going to approach this problem is like there are certain algorithms. Okay, cycle detection algorithms. There is hare tortoise algorithm, and like it is also known by different names, so we can use that. So basically we'll be using two pointers, and there will be one fast pointer and one slow pointer. Okay, so fast pointer will be taking two steps and slow pointer will be taking one step. So in a cycle there will come a point where the fast pointer will come across the slow pointer, right? And that is exactly the point we'll come to know whether a cycle is present or not. Example like how we have in a relay race, like if we have to complete multiple laps and we have a runner who is running faster, we'll definitely come across a slow runner, means we'll definitely pass by a slow runner, right? That is exactly the logic that applies here, and how we are going to understand whether a cycle is detected or not. So we have a pointer. This is for the fast pointer and this is for the slow pointer. Okay, so initially, we'll have a node pointing to the very first node or the head node, okay? And we will move the blue pointer one step and the red pointer two steps. And then we will check if they both are pointing to the same node, okay? If yes, then we return a true. If not, then we go on in the cycle up until the point we see a null or we come across the same node. And that is where our program ends, okay? So in our, consider zeroth iteration, and our slow pointer will move one step, okay, and our fast pointer will move two steps. Now we will check if both are pointing to the same node. That is not the case, right? So our loop will run again. So when we are starting with our loop again, let's just consider this one to understand better. Okay, now again our blue pointer will be taking one step. Sorry. And actually in that same iteration, the red has to take two steps, right? So at this point we are not checking. At this point, like, it has to move two steps. So this is one step and this is another step. Okay. Now, at this point, we are supposed to check if they are pointing to the same node or not, which is again not the case. So again, we move on to our next iteration. Okay. Now again, the same drill. We have to move blue pointer one step and we have to move our red pointer two step. And here we come across a situation where both our uh, nodes are meeting, right? And we will return a true. That is simple and that is all we have to do. Okay, so let's code it. First, we are going to check if head is null or not, or the next of head is null or not. Then we will return a false. Then we need our two pointers. Let's call it fast, which will point to head. This will also point to head. Now, what we don't need in a cycle is a null, right? Or the next node being null. So that is the checker we are going to put while fast, because fast is going to traverse faster and find out if there is a null or not, right? If fast is not equals to null, or fast.next is not equals to null, then we are running this. So what we do is slow will be slow.next and fast will be fast.next.next are two steps. And in our while loop itself, after we like proceed them further, we are going to check if slow is equals to fast. If that happens, then return true. And if that doesn't happens, then we will return a false. Because if it comes across a null, then we are done, right? There's no point. I mean, not expecting any cycle. Okay, sorry, it won't be or, it will be and. Yeah, because both the conditions are important. My bad. Okay, so time complexity and space complexity is O of n, as in the worst case. I mean, anyway, we are traversing through the entire like linked list. And space complexity is O of 1, as we are not using any extra space. So thank you so much for watching this. I hope you guys understood this was a easy program, and let's catch up in the next video.